Hello, gentle readers. It's November 1, 2025. Today is Reading Foundations, where besides the usual notions of the key components of the traditions of the logic and philosophy, like Hegel here and Aristotle, then there are so many wonderful books that each have their own perspective, their lens. We're postmodernists here, and so the idea is that it's possible to always think through things and to consider not just the necessarily the intended of the text or as of what would be received as a text by various model readers of sorts. That furthermore, the entire deconstructive account makes then for that being structuralists, because deconstruction gets deconstructed and results structuralism instead of the mise en abîme, sort of the wellspring of from nothing in the fundamental question of metaphysics, a place more than a setting. Then one way to think about that is that for the logic and philosophy is that it's true. We discover it, and then of course, conversely, yet just as apropos, it's science, and we postulate and theorize these things, and furthermore, then discover them. And so this is as opposed to the idea that mathematics is invented, say, or that our consciousness, which has its own spark of consciousness, and so in a sense is its own objective place. That as well, where besides all being intersubjectively each individuals, that we're each interobjectively our own individuals. And so that makes for thinking beings and feeling beings. A pretty much great account then is for the usual notion of freedom vis-a-vis fate. That altogether, this I find is really the most comfortable sort of prospects in outlook, because otherwise there could be derived all such manners of the paradoxes, the contradictions, the inconstancies, the hypocrisy, and other things that are deemed, in a sense, wrong. So it's not here matters so much of the absolutes as ethics and morals in the human condition, because it's considered in the mesoscale, as that may be, or the micro scale, that is subjective, it is relative. Yet as well, it is understood that there are the virtues and the vices, and that the means and the ends are two different things with regards to that. It reminds me of discussion about the means and the ends. And do the ends justify the means? Meaning, what goes on with regards to goals and needed outcomes or desired outcomes with regards to the methods employed to so reach these goals. And so do the ends justify the means? And here the answer is no. The ends justify the ends. And then the means, as pragmatically or de facto or vis-a-vis the prior and posterior, aren't justified themselves, because means are their own ends. And so with regards to things like first principle and final cause, it can go to show that overall in a weighing and a balance of things, that the ends are still justified regardless of the means, but that the means themselves are not justified by the ends, because that might never be reached, or that's merely hypothetical. And so basically what this says is that there is free will, and thus there is personal responsibility and individuality besides enterprise and matters of actions with regards to perceived gain for the self, or the selfless gains is sometimes put. So the ethics and morals aren't so much addressed here, but they are recognized. And so that then goes kind of more so without saying them with regards to the mores and the kind of the principle of least astonishment and these kinds of things, and not being contrarian for contrariness' sake, yet still as well employing the wider, fuller dialectic to help make it so that otherwise what would be underserved notions don't get further relegated to the contingency and the potentials of what should be their fulfillment. That instead, here, it is again mentioned, is pretty much a comfortable place, a happy place, a gentle place, and that then thusly all such matters of otherwise strategy and tactics or the adversarial settings can still just be considered very obliquely as objectively vis-a-vis the logos and the kairos, meaning the logic, and then for the timing of the things, that the ethos and pathos, and one could put ethos and pathos together either way, the ideas of the should for ethics and morals, and the feelings of the pathos have that those are to be disambiguated from the technical and technoanalytic setting, because well, at the same time, it's not to like let science dictate the terms as being just another system of the world or the fates and this and that. Still has it so that then for the objectively and the logical, that then the logic won't be swayed by ethos and pathos. It will be necessary to eventually accommodate that such sorts of arguments are on their own terms. And then as with regards then to the meaning of that, then I'll just leave it at that. So it's a box of books, a random selection. But the books were selected for some notion of their enduring value. So yesterday or last time it was mentioned looking at books about particular mathematical subjects like constants, the mathematical constants, the transcendental constants. For example, E, I, pi, and phi. Whereas phi, I suppose, is an algebraic constant. It's not transcendental, but E and pi are transcendental. And then I is considered a particular leaf or leg, as after, besides the principal branches, just kind of like negative numbers, that it's the imaginary number. Then for things like that, or books on the circle, or otherwise focusing on these central and primary elements of what result geometry and number theory, that before even getting into stuff like infinity, that then these transcendental notions and what arrives as of them as the super-classical mathematics, which is kind of just above lines in the rational, yet still part of the replete here, has that those are considered pretty good. So what I'm kind of reading more thoroughly is that the story of square root of -1, or I, the imaginary number, and as with regards to the ideas that have arrived from it, and that, as the author notes quite in the beginning, that even thousands and thousands of years ago, algebraists as far back as the Egyptians and Sumerians already had that sort of concept. And that the idea that so many of the sensible, fungible, and tractable areas of mathematics are essentially overlooked because the usual methods suffice for so many matters of the ordinates to find things, that it's just then goes to show that there's so many aspects of this, as it's put here, this Hilbert's infinite living, working museum of mathematics, as an idea of kind of like the treasure and the store of while it's alive and indeed contains the study of it, the living, working museum of mathematics, named for Hilbert, for Hilbert's Infinite Hotel, that is infinite. Then is that then these readings will just kind of so follow as about these kinds of things. So reading foundations won't necessarily have so much of a course, but probably it'll end up being sort of identified that to start with something about reading and then just some reading, and then to relate that to particular authors and their schools as with regards to then concepts, and largely for enrichment, where enrichment means to have that besides the standard linear curriculum that everybody needs to know to progress from grade to grade and pass school. Then that the enrichments help further to make that and facilitate that and make possible the higher order thinking, the higher geometry, the higher or advanced calculus, say. The Quantum Universe, Cox and Forshaw. This is about quantum mechanics, and I don't recall anything particularly compelling from it. Out of CERN and the University of Manchester. Outstanding contributions to theoretical physics. Breaks the rules of popular science writing, which has that every formula equation added halves the audience in half, halves the audience. Breezily written, accessible, Planck constant. We should not be worrying too much about the pure numbers, which is why we just bundled them all up in the symbol K. It's worth noting that K depends on the ratio of Z and A, and so will be different for different kinds of white dwarf star. Bundling some numbers together into one symbol helps us see what is important. So this is kind of like when you think about something like energy, and it's like, well, it's physics. What's the quantity? Well, we got energy equivalent to everything. It's all energy. It's like, oh, where is that now? It's like, well, it's in the entelechy, which is a word for a continuum. I mean, and it's in the space-time. It's according to field theory, it's in the field number formalism. So it's somewhere, and it's a given place in a given time. And so it was energy, 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 and energy again. It's like, well, yes and no, because there's no such thing as pure energy. It's always in a form. And so it's similar to this notion of this algebraic and the derivations as discussed here. It's like, well, when you get something in a formula, I mean, and in one sense, that's the quantity and it's the parameter. So as with regards to other elements in that, you can treat them algebraically. And for example, all the arithmetic that's usually associated with the numerical quantities and algebraic derivations. Whereas for things like category theory, moving things around according to their types. So what the authors, though, reflect here on this being that this is a reduction of sorts, an abstraction, the weak and strong get applied both ways. So what's weak for one set of results is strong for another, and what's strong for one set of results is weak for another. So it's a trade-off, and it's a compromise in a sense. And then what happens when there's complications above what was made for the reduction and trying to unify things that were reduced their distinguishability, that then this gets into why sometimes this is a simplification. Well, it's helping just express that this is just like it's symbolic. And so that's familiar to anybody from dimensional analysis and the ins, outs, and the setups and stuff like that. Here's the other side of this is considered more replete and necessary because this is then lost the distinction. And so when it gets to like the principal branches in singularities of what are multiplicity theories, in mathematics this is called the openings or the perestroikas or the catastrophes sometimes, about things like the roots of 0 or dividing by 0. Or for example, numbers to the 0th power is one or the other. Or for example, roots of numbers, do they always include the positive and negative in any other number system, which has their factors as products that together that result these numbers and they're real analytic. So the point of just this brief, altogether brief sampling and picking up on this because it's just describing to somebody how to work together these terms is then it has, so obviously the size of our little cube and its location within the star are completely arbitrary. None of the conclusions we are going to draw about the star as a whole can depend on the details of the cube. So this is analyticity in a box, basically. And the fact that it either does or doesn't have a soul makes it sensible, fungible, and tractable, helping to explain why this gets into this dimensionless numbers. So here after the Buckingham Pi and the dimensional analysis, as the dimensionless analysis has that's lost meaning. And so in the real physics, all the fields put together, it has all their dimensions together. And even in motion itself, it has implicitly all these higher orders of motion, so canceled at the balance, at the dot, at the final inkling of the thing, that is implicit, that these implicits are part of the derivations. So it's more of a dimensioned analysis. And while it is so that the reduction, as it is, it's called the abstraction, or the reduction is so, it's very sensible, fungible, and tractable, it is not necessarily complete. And for that matter, it's an exercise in reduction. And so when trying to get back into the bigger things, and all such manners of numerical methods find themselves placed as for notions like Hooke's law and Clausius and Arrhenius and for Lagrange and these kinds of things that on the one hand are finitely bounded, but on the other hand have lost a part of the higher geometry, the outer of these products. So that this is going to show that even as part of a development, helping somebody read through a derivation and arrive in it formulary, that it's not without its costs, its benefits. Talks about dimensionless numbers and the cube wall, because when you have black holes and singularities, you get to the issue of the cube wall. It's like, well, what's a black hole? It's like it's a gravitational singularity, and according to Chandrasekhar and Schwarzschild radius, that's what it is. According to R, it's just like that nothing could get out. It is a singular attractor, according to things like dynamical modeling of the chaos theory or something like that. It's like, well, so what shape is it? It's spherical, because if it were anything less than spherical, it would immediately establish back its spherical form. So, well then, what does it look like from one side to the other? Well, from one side it's spherical and the other side is flat. So it's making like this cube wall. So what does this get into? Well, it means whenever anything hits the wall, it becomes a spaghettification. And so it's going on in all these spiral space-filling dimensions at once and runs itself out. It's like, well, so how does mathematics deal with it? It's like, well, if you point a straight laser all the way directly through the thickest part and reach directly to the center, it's linear. And everything about the classical applies, because all classical mechanics is built just only that way. And it's like, okay, great. So then it's just always like that, and we can use that to build everything? And the answer is no, because in the real world, it's never like that. It's always nominally unlinear. So all these things like for moment and motion, about motion itself, and about how it can be that there can be bends or turns at all, and what those mean to carry the continuous course of them, then is kind of more fully addressed there about the dimensioned and the dimensionless. And the analysis, because just like the dimension has all the implicit dimensions, meters per second, per seconds per meters per second, per seconds per meter ad infinitum, and just like any kind of quantification of elements, there has in front of it implicitly many universal quantifiers. These are just ignored, but at the same time, when we get to issues like compactness and the total, then they are not ignorable anymore. And so to make the complete and replete gets into this is a super classical sort of setting. So, and the mean density. So now instead of the means as the methods, these are the means as of the averages. The average density, rearranging the equation. Now, lambda only depends upon the dimensionless quantities, A, B, F, G, and H, which means that it does not depend upon the quantities that describe the star as a whole, M and R. And that this means that it must take on the same value for all white dwarf stars. If you were worrying what would happen if we were to change A, N, or B, which means changing the locations and or size of our little cube, you have missed the power of this argument. No, it's like it's recognized that is an argument, but here it's known that the anstos or the inductive impasses cannot complete themselves. So this is the invincible part of the ignorance picking up. But it is impossible, because we know that the cube root, and this is about the cube wall mentioned, is something that depends on the star, not on the specific properties of a little cube that we might or might not care to dream up. So that's with regards to logicist positivism, this is just help making an attachment that for things like the Machian and this kind of stuff that's like so, because otherwise, this sort of development is very Lagrangian and it's kind of like the post-Lagrangian, and these aren't so necessarily needful in a simple linear classical calculations, but they do end up becoming a deal, and then that gets into why it is so. Here it introduces flux. Here one of the concepts about flow and flux is that flux is super classical flow. And so the idea then, whether that's like attenuation of the floor for matters of flux in a local setting, but that usually it's just kind of the opposite of flow, just the notion that, well, whatever has to give in terms of the open and closed circuits. And here's talked about the pressure. Compute the pressure saturates, and the gas is not capable of delivering electrons to the mirror at a sufficient rate to maintain the P or rho of 5/3 behavior. The same argument is in the non-relativistic case. So they've established at least two extra projections necessary. Matters of projection and the perspective. That this gets into in these derivations that balancing the equations. And then what happens when it arrives at the usual classical accounts would be like, well, how do electrons float around their orbitals? Well, they would collapse. Well, it's like, why don't they? It's like, well, they just don't. That's like the classical paradox usually associated with electrons in their orbitals and the degeneracy of their orbits, which is classical. And then and so they're no longer of that kind. The electron orbitals are like this middling road itself built by the inductive impasses either way, but it was already picked because that's the only way all these things add up, and they do so very neatly. And so then with regards to this also like the collapse of things, it's a similar kind of treatment that the authors are stuck that they somewhere then that the middling road already picked has guaranteed that it's either on the ridge or in the ditch. And in this case, then that's where it is. And so this is the end of the book. And it says, this really is the end of our journey. The calculation in this chapter has been at a higher mathematical level than the rest of the book, but is in our view one of the most spectacular demonstrations of the sheer power of modern physics. Well, it's funny, they use the word sheer, because sheer usually means like shear as in, there's shears, and then shear as in the surface. So it's either surface or the cutting. So SHEAR and SHEER, here is written SHEER, the shear, with regards to stress and strain and shear, and the transverse, has that as kind of like so, that it's made for a particular branch. So it's a very Gaussian approach, it's a very Eulerian approach, it's a very Lagrangian approach, it's a very reductionist approach. But it's about the shear, but not so much like the mountain of the face that's impossibly high is what it is. It said, modern physics. To be sure, it is not a useful thing, but is surely one of the great triumphs of the human mind. We use relativity, quantum mechanics, and careful mathematical reasoning to calculate correctly the maximum size of a blob of matter that can be supported against gravity by the exclusion principle, or Pauli, usually that is Pauli principle. This means that the science is right, the quantum mechanics, no matter how strange it might seem, is a theory that describes the real world. And that is a good way to end. That is first of all, it says that science is right. Science is never wrong, regardless of what quantum mechanics it says. And then quantum mechanics then is a theory that describes the real world. Is notice it's like it was picked and chosen which of these things would keep it from breaking itself. And the careful, as our deconstructive accounts might say, the difference, the lateral dance, to arrive at that sort of waffling. And he suggests to read, or they suggest to read Feynman's QED. I have a copy of it here somewhere. For those who search more detail, the very best book on the fundamentals of quantum mechanics is, in our view, still Paul Dirac's book, The Principles of Quantum Mechanics. So, electrons, their orbitals, well models and spike models, and different models of change and potential. That's the idea usually. Atoms and their clusters, atoms and their subatomic particles, which are apeiron, which are contradictions in terms. The Pauli exclusion principle says that the two electrons cannot be in the same quantum state because electrons are indistinguishable fermions. You might be tempted to say that if the atoms are far apart, then the two electrons must be in very different quantum states. So from reading O.W. Richardson's, one of the greatest books to read about the electron theory of matter, called The Electron Theory of Matter, is that he helps establish that the Pauli exclusion principle is like a branch, and the very idea of the development being nonlinear, unlinear, is established in O.W. Richardson's book, where also he establishes that there are at least three constants called c, which is usually just reserved to light speed. It's reduced to that, that show that for electromagnetism and electrical dynamics and the statics, that there are different ones. And then these constants, as were mentioned, are running constants. Well, is that a contradiction in terms? Yeah, it is. But it indicates that these constants scale along with these other factors and their interactions. So it just goes to show that even though Avogadro's numbers seem so perfectly precise at 6.022 times 10 to the 23rd or something like that, atoms per mole, yet as well that just like it has that the big sciences, particle data groups out of NIST, CODATA, every few years releases new physical constants, and they change. And they don't just get more precise, like 6.0223 or whatever it is. They get smaller. And so just like the universe gets bigger the more we look, the particles get smaller the more we look, help to show that really is a continuum mechanics that is never wrong. And it just needs the mathematics to get it right. Because all this stuff essentially is just kind of algebra, and then it somewhere is using numerical methods and partials, it's incomplete. Well, it's still just what it is, and it's so great, and that's what people can get to. Planck's constant. Heisenberg versus Schrodinger. Is it before or after the observable? Is it classical or non-classical? Heisenberg and Schrodinger. How about Bohm? He says it's real. This is a realist philosophy and an anti-reductionist philosophy, or the holistic, as it's sometimes called. Whereas quantum mechanics is by its very definitions, not those things. So what this is, I mean, it's a good book, but yeah, I kind of have to know the context to what goes into it, and then also the context that is above it. This is literature of sort. Oh, this is criticism. This is Oliver Evans on Anais Nin. So this is from Southern Illinois University Press. And so what this is, the modern critiques, cross currents, modern critiques. And so the authors, let's see, I'll just read the introduction here. Since she began to attract attention as a professional writer in the 30s, Anais Nin has become widely known among the international avant-garde. For many, she is a symbol of freedom, excitement, and discovery. Following the literary pioneering of Joyce and Proust, Miss Nin has succeeded in introducing new dimensions into fiction. So often that would be considered part of the sexual, and thus involving the psychosexual, and in matters of gender, and such notions. And for then the kind of crowd is of like the smuttier side of literature. Yet as well that is held up as having literary character is a thing. So that then, that said, then this author talks about issues like ideas of the self and about the diary and these kinds of things. And the influences and the surrounds of the people. Then for Henry Miller Henry Miller is rather a nut, but his books are stream of consciousness, and so there's kind of like Dirty Joyce in a sense. James Joyce, who is considered one of the greater authors, and his style is stream of consciousness. So that said, Joyce is considered quite more sober and profound, yet a field, whereas Miller is manic, and then that Anais Nin is cerebral and in a kind of in a dreamlike state, and so that gets into matters of the psycho, sexual, and then also the matters of the narcotic and the how one might say the detached furthermore a bit from reality. And so there's not so much to be said with regards to the psychosomatic or the psychoactive or the psychedelic, those being considered states that may be parts of catharsis or experience in any such manners of thing, that everything is so grounded is also so high in a sense. That then this kind of material is part of criticism and part of the underserved, in a sense, part of the literary, because to some these topics are immediately anathema or considered dangerous. And so this is for matters of literary criticism and the critique as vis-a-vis these lenses of these authors and the zeitgeist of their times and these kinds of things. Talking about here, for example, transmutations. And so it's just exercises and plays on words. And it's matters of experience and expression. Talking about the labyrinth. And so this gets into symbology, as is written, or is read from Cirlot. About many of the books. So this is a reader who has read the entire output that can be found of this author under criticism to help explore these things. The book is a kind of epiphany, a celebration of jeunesse dorée, the idyllic period before the lack of faith, that mysterious substance that shines from the body like phosphorescence from the albatross, describing his impressions. The flashbacks establish that. The memories, the experiences, the expressions, dancing, a reverie, a dream. Her experiences. The book is marred, moreover, by certain repetitions that, unlike the repetitions in Proust or even Gertrude Stein, which have a thematic raison d'etre, seem to serve no strategic purpose. Well, not all writing is profound. Yet, given that one has a profound background or outlook, anything kind of has its place. Not all pulp is pulp. Which we may, from the viewpoint of existential psychology, which holds a lock that a man's character is a sum of his experiences, and that he defines himself by a series of conscious choices, challenges the concept of a basic self as mystical and idealistic. We may, in short, refuse to share the author's assumptions, but this does not mean we cannot share the fictional experience which offers to us out of her gift as an artist. The act of reading any novelist who has definite convictions about life, and this means any novelist of interest, requires for his fullest appreciation a temporary abdication of our own convictions for the sake of an aesthetic reward, which justifies the sacrifice. So this is part of the deconstructivist account, but that's also part of the voluntary account. And so those being kind of two different things. And so there are many kinds of readings as discussed here, from the consideration of reading for pleasure vis-a-vis reading for information. And so having the critical stance always does have a separation between what's read and what's being read, but it is a matter of experience. And so it is rather vicarious vis-a-vis being in it. And so some people, just as with regards to the ideas of being graphical learners, are entirely subject the experience. And back to the Japanese proverb, if you believe everything you read, maybe you shouldn't. This just gets into the otherwise, that giving a generous reading of things is always a kind of a given vis-a-vis a very circumspect reading of things, and being basically for matters of good faith, one might say. It is true that the sacrifice is greater in the case of some writers than of others, and here two factors are involved: the degree to which the author's convictions differ from our own, and the extent to which the assumptions are woven into the fictional fabric. In the case of Nin, the fiction sometimes suffers because the narrative is made to depend too heavily upon the intellectual assumptions, so they assume proportions which, particularly if we do not share them, may sometimes be incommensurate with the rewards of the sacrifice, or cringe, or what you might want to say. But these are ideas that it can also be reversed, because now this is the author reading through his own lens, and so we can everything is recursively deconstructed. The intellectual value of Proust, of Joyce, and of Lawrence is also negligible, and of the three, Lawrence requires the greatest sacrifice for the reason just mentioned, that his assumptions are so much a part and parcel of the narrative, he cannot resist the temptation to thrust them upon the reader. So that's about being a generous reader and a generous author, and as well being a challenging, or in the sense of offering a higher value, the writing that is some kind of thing. And the intellectual value is often just the experience of the exercise of parsing and grammar, to then be able to say, well, anything less than that is easy, and this kind of thing. The fact that Tolstoy idealized the Russian peasant out of all resemblance to reality does not prevent Anna Karenina from being a great novel. In the last analysis, the value of a work of art must be demonstrated on aesthetic grounds, and the literary critic can make no worse error than to praise an author because he happens to approve of his message, lest it be that of censuring an author because he does not. The honest critic will forever be on guard against errors of this type, or these types, which end in the kind of aesthetic blindness from which Tolstoy suffered when he pronounced Uncle Tom's Cabin an important novel, which F.R. Leavis was the victim when he declared Hard Times to be the best of Dickens, and which anyone is guilty who claims C.P. Snow as one of the most important living artists. So that's definitely the author here casting shade on what he doesn't care, because those are considered literature and literature and literature again. And there's all levels of readers, and to each of them there's all those kinds of things, vis-a-vis stuff that is doesn't say anything, and as with regards to what does, and also with regards to, besides the ethos and the pathos, the logos and the kairos, that in a time and a manner it's like a work that today would seem just mundane or anachronistic, at the time it could have been very apropos. So this is an exercise in criticism itself, and then a study of the works kind of like here. There's the Nietzsche Register, which has got all the works of Friedrich Nietzsche. There's like so. So it does mention Descartes at least once. So let's see what's mentioned of it. Juna's ideas, which you gathered from the diary, also the author's, remind us irresistibly of Descartes' dictum, conquer yourself rather than the world, and even more forcibly, perhaps, of Whitman. The earth, that is sufficient. I do not want the constellations any nearer. I know they are very well where they are. I know they suffice for those who belong to them. So that's just kind of like this classical milieu discussed from the quantum physicist just now. It's like, well, that is don't boil the ocean or something like that. At the same time, the grandiose, ambitious accounts are total and are universals. And Descartes' elementary accounts and his notions of the universals are quite more profound than just that one quote by itself. So it's not, again, that's so much that it's out of context, but it's not in the context. Enzyme physics. Okay, Vol'Kenshtein. This is back into physics, and it is about the higher order physics. And what it gets involved with regards to enzyme physics is that molecular reactions and chemical reactions, according to catalysts, how that catalysts in present reactions may not be among the reaction products themselves, but their presence makes it so that the reaction can happen. And then enzymes are considered these catalysts that furthermore are they're not consumed. The catalyst is kind of the usual idea that an enzyme is a very powerful sort of catalyst because a minimal amount makes for an entire chain of reaction. And so that's kind of an outline of what enzyme physics is. But what Vol'Kenshtein gets into is these issues with the near field and far field, the linear and the unlinear, and these kinds of things that let's look at this some more. So on the back cover is some other books, and this is from circa 1969, from the Consultants Bureau, Plenum Press, IFI Plenum Press. So before there was Mir, this is this, kind of so translated from Russian, concepts. So from the Institute of Molecular Biology, the Academy of Sciences of the USSR Moskva, translated from Ruski, considers in detail the three major problems in enzyme physics: genetic coding and the functional structure of proteins, the conformational properties as a factor governing enzymatic activity, the manifestation of the cooperative properties of enzymes, and the kinetics of enzymatic reactions. The author discusses techniques for the solution of kinetic problems and devotes an appendix to use of graph theory. The second appendix considers a Faraday effect in relation to problems of optical activity. Emphasis throughout is on physical techniques and physical chemical approaches. So this employs higher mathematics, employs nonlinear analysis, and otherwise it's a nice heavy book. This book treats a new, far from fully developed area of molecular biophysics, enzyme physics. The first problem is the genetic coding of the biologically functional structure of proteins. The solution is based on physical theories of hydrophobic interactions. So the hydrophobic and hydrophilic get involved with the universal polar solvent and the fact that, as mentioned before when discussing about the spinors in the quantum, about the bonds and the bond angles and the vibrations of the resonances, that it's not just the Tinkertoy model. And so the solvent that is water is in a constant state of activity while some zero. And so that's just because in any given temperature, the things are moving around. And then with regards to enzymatic activity in the active sites and the conformational of the protein structures, the proteome, those great and grand diagrams of either the spirals or the sheets, and then the fingers with regards, for example, to the zinc finger and these kinds of things that make it so that these various catalysts and what make for being enzymes, as with regards to the proteins and the proteome, these dynamics of the reactions, that this book gets into about the hydrophobic and hydrophilic of the nature of water as a universal polar solvent, and it's the idea that, well, humans are 2/3 at least made out of water. That it's a very active state besides just being a given temperature and a given state of matter. Second problem is the conformational properties of proteins as a factor governing enzyme activity. So this is folding is what it's been put today. Solving protein folding was supposedly the biggest, hardest problem in the 1990s and since the 1960s. And it still is kind of today. But a lot of things that they've been able to figure out with Amber and Chime and these other systems for molecular modeling, that molecular modeling is a field. So there's dynamical modeling is like, well, anything parameterized by time. And molecular modeling is like, well, when it's molecules, which are made of atoms, but above them. So all this structural molecular chemistry gets involved. So they put them in the simulator, and a finite element analysis is what comes out. It's like, well, nothing came out. It just doesn't add up. And so then putting these other things in it, these are part of the things. Third problem is the manifestation of the cooperative properties of enzymes, the kinetics of enzymatic reactions, and the solution of complex kinetic problems. So here, kinetics and kinematics are further separated. There needs to be mechanics itself for classical mechanics and physics figured out before this is even kind of well defined. This is a great book, though, and Volkenstein gets into some higher mathematics within the development of this. And that's in a lot of these studies about, for example, population dynamics, or from the numerical methods and the dynamical modeling, the dynamical methods. There's so many cool ad hoc ways that have been kind of set up that work out and give reasonable ideas, and that's part of the enrichment, because there's an entirely many myriad demonstrations in this Hilbert's Infinite Live and Work and Museum of Mathematics that are powerful and sharp tools that very few people know about. Appendix 2, anomalous dispersion of magnetic rotation. And so this might have something that kind of speaks to the modern zeitgeist problems with physics' crises. Since everybody, it's well known that, for example, as Penrose puts forth in Fashion, Faith, and Fantasy in mathematical physics, general relativity, which Einstein's theory always being confirmed, and quantum mechanics, Dirac's or Feynman's or whatever theory is always being confirmed, disagree. 120 orders of magnitude. They do not agree. So they can't both be right. And so that's it. Making them both right is for continuum mechanics and these mechanics getting fixed. And then fall gravity. Enzymes, catalysts. Protein structure, monomers and polymers, usual chromosomes, according to proteins, and the study of those has that when you think of Gattaca or whatever it is, guanine, taurine, cytosine, and A, whether that is, and those being the building blocks. I'll need to refresh a little bit my study of this. The theory, that the central dogma after molecular biology, then into the ideas of the monomers and the helix and that form of structure in regards to then the alpha and beta, spirals and sheaves, and the usual ideas of proteins and structure. This is kind of the theory. So it starts with the matters of diffraction and the rational and sums and terms and quotients. Here we have a deconstructive account of mathematics. The numbers as having additions and increments separate from division altogether. Long subtraction, it's called. And then the values of observable things for different kinds of the triangles represent aggregated proteins, and the crosses represent proteins that have been found to have an elongated rod-like structure. Salamine, insulin, ribonuclease, lysosome, myoglobin, whale, myoglobin, horse, papain, chromatrypsinogen, structural protein, corticotropin, ovomucoid, pepsin, carboxypeptidase, prothrombin, beta-lactoglobulin, pepsinogen, ovalbumin, edestin, alpha amylase, tropomyosin, plasma albumin, human, plasma albumin, bovine, avidin, hemoglobin, horse, coenalbumin, globulin, human, aldolase, thiophosphate dehydrogenase, leucine aminopeptidase, phosphorylase, glutamine dehydrogenase, fibrinogen, beta-galactosidase, beta-galactosidase, myosin. These being what they had and what they could figure out for these things, and what become relevant, because these are like the surrounds of the reactions along with the universal solvent, water everywhere. Here's a table of these proteins under consideration and some other ones. Nevertheless, the result of Fisher's work can be regarded as strong arguments in favor of the theory that hydrophobic interactions play a decisive role. So this was hydrophilicity or hydrophobicity with regards to protein folding. 30 more years before, from 1967, this was published originally, 1969 in English. Then the hydrophobia is usually also called rabies, but here it's about the water molecules are unbalanced, they're poles, and so there are little magnets everywhere, the oxygen and the hydrogen. Tier says, actually, Tier exhibits both polar and nonpolar properties. Analysis of the structure shows that these 33 residues are located in the side of the alpha helix facing into the globule. On the other hand, the residues of the globule surface do not obey the simple rule pointed out above. Polar residues can be replaced by nonpolar residues and vice versa. The existence of a hydrophobic core in the globule has also been confirmed by investigations of the denaturation of proteins by slightly polar organic solvents. In such cases, the nonpolar groups of the protein are in contact with the nonpolar groups of the solvent, and the hydrophobic structure breaks down. The strong denaturative effect of urea is attributable to this phenomenon. On the other hand, water molecules can be incorporated into the intraglobular space and even into the intraglobular interstices when a quaternary structure is present. The rule of thumb described above may not be observed in such cases. In concluding this chapter, it should be emphasized that a protein globule is a compact structure that differs materially from a randomly folded coil. The amino acid residues within the globule are in contact with one another. The globule can resemble a drop of liquid in this sense. So the droplets and the wavelets and the matters of shape and form, and that being for things like the metric and norm and the disk. And then for things like the sphere and the disk, and then the spiral-spacefilling-curve, and the outside being that, also relate to things like the cube wall and the spaghettification of the singularities involved. that the large-scale cosmological physics and treating things like particles and the small-scale quantum mechanics and treating things like particles are a lot the same. And so then trying to figure out the superclassical effects and get involved with them are a lot the same, which is nice. See, Appendix 2, I want to just briefly look at this. Magnetic properties. It began, and it has quite a bit going on in it. It's a significant amount of things. In 1846, Faraday discovered a phenomenon they called magnetic rotation of the plane of polarization of light. So here this is called, he polarized the light. And it's from the World FactBook of 1846, which is read here. It's a book from 1846 where this was brand new news. And when light polarized parallel to the magnetic field, this gets involved. He had it set up with like with regards to the sodium lamp or the hydrogen lamp, and then the hydrogen has only got one spectroscopic line. But when it gets to spectroscopy, well, sodium has 3 spectroscopic lines, and they only pick one. And so like Zeeman later, he got his Nobel Prize in like 2000 or 1902 for something like. Well, actually, I undid it. So Faraday's is not an effect. So that way, because otherwise it wouldn't clear the way that then this mathematics of this simple sort and the linear, associative sort wouldn't add up. Well, anyways, but this is where the author's like, and so anyways, Faraday magnetized the light. Phi equals VLH. When light polarized parallel to a magnetic field passes through any substance, the polarization plane of the light wave is rotated by an angle proportional to the thickness of the layer of material and the strength of the magnetic field H. Phi equals VLH. So this is it due to light in a medium. So this isn't light by itself. This is really the magnetizability to lead to a polarizing effect of material medium. Because light in a vacuum does not see this, is the idea. And so light, according to like the Zeeman effect, would have to like not either, because then it would add up, but it does in any material. It's not in deep space. So, and then there's basically, well, if there's an opposite of light in deep space at a vacuum, what is it? It's like the opaque, vis-a-vis. What does that do? It just reflects or absorbs the light and converts it. It's kind of like the same notions as for gravity and the potentials getting dissipated to zero. It's kind of like that for light, too. Faraday wrote, I was ultimately able to magnetize and electrify a light beam and illuminate a magnetic line of force. This is naturally a figurative statement, the author puts. In actuality, the Faraday effect essentially consists in the action of a magnetic field on a substance, so that it acquires circular birefringent and circular dichroism. So, birefringence is after the diffraction and refraction, which only light has, and various nuclear rays, but not electron beams as they're usually put there. Although variously, that's kind of made in accord because of the interaction of the materials and this kind of stuff. And then dichroism here relates perhaps either to the second spectrums of light, as for example Newton explored and was read from Ogden Rood's the modern theory of light, and as well this the dual tristimulus color space of light, and light being special, and these kinds of things that the author mentions here, because then you could in their labs they could use this to like, because spectroscopy wasn't working for their molecular models, they could kind of denature it and get out like, well, humans are made of 1/3 2/3 water, but to get like a better idea what's going on, that this kind of thing is practical. The Faraday effect is therefore observed in all compounds, regardless of the symmetry or asymmetry of the molecules. It is obviously that, having different causes, the Faraday effect can yield different information on the structure of compound than study of optical activity. Well, it's kind of combined. In seeking new ways to investigate the structure of biopolymers, it is natural to turn to the Faraday effect. So here the Faraday effect is then made for this flow and flux that it's all got to come back together somehow. That's more complete. The origin of symmetric DMR is readily seen. The curves for the dispersion N, which correspond to the components of the Zeeman splitting, are identical but displaced relative to one another. The value of phi is expressed by the difference in these curves. The difference delta N is the form of a single curve with a minimum or with two minima at large. Since the natural widths of the molecular bands are far greater, only the first case can theoretically occur in the molecular spectra. Well, except around bends and corners and this kind of stuff. This type of anomalous dispersion of magnetic rotation, ADMR, was first observed by Macaluso and Corbino in sodium vapor in 1898. See also. So this is about Macaluso and Corbino before Zeeman, and about though after Faraday, and that this is what they're this was before electron microscopes and stuff like that. This was the most critical thing to get very fine spectroscopy results. Symmetric ADMR is called the Macaluso-Corbino phenomenon. It should be quite pronounced and very sensitive to the positions and intensities of the spectral lines. In essence, there's an interference or interacting terms or difference effect within a given absorption line band. Classical treatment, and so he separates the idea of the lines and the bands. The classical treatment of magnetic rotation is based on consideration of the inverse Zeeman effect, i.e. the Zeeman effect in the absorption spectrum. Direct observation of the Zeeman effect in molecular spectra is greatly hampered by the small magnitude of the splitting. On the other hand, the Faraday effect is readily observed since we are not dealing with ADMR. All the foregoing pertains to diamagnetic compounds. Paramagnetic compounds exhibit a Faraday effect governed by the orientation of the molecular magnetic moments, mu, and hence are temperature dependent. So getting involved here, all the things. That light is free, and so it goes all the ways. The rigorous theory of magnetic rotation is naturally a quantum mechanical theory. So that is just saying that that's elementary in the account. It was developed on the basis of perturbation theory, has been considered in a number of articles. So that's just saying it's like, well, it's super classical, and so we have to give it, the quantum mechanical account here is the probabilistic account. And so when you hear perturbation theory and quantum mechanical, that's not continuum mechanics, and so that just goes. So why it's so natural is because that's kind of all there was available to that, and the idea that then, well, the whole idea of all the quasi-invariant measure theory and the pseudo differential and all that would be necessary to add it back up, it has to come up from all the stack that this is already built on. Which is irrelevant because that's what we want. Then as mentioned, for example, the lack of analogy between the classical and quantum theories of magnetic properties is also demonstrated by the fact that the Zeeman effect is associated with Larmor precession. So Larmor forces, Larmor is got a lot of things that are associated with the unlinear, or the non-classical, or the super-classical, or the kinematics. Larmor precession. And hence with diamagnetism in the classical theory, and with the presence of natural orbital and spin moments, i.e. with paramagnetism in the quantum theory. This difference results from the non-rigorous and inconsistent character of the classical theory of diamagnetism, which tacitly assumes that electron orbitals in the atoms to have a quantum character. Strict classical theory should lead to zero diamagnetic permeability. So this is that, saying that quantum mechanics is never wrong, it's like it can be done three different ways, at least one of which is wrong. So that must not be the way. The Becquerel mentions Becquerel, Macaluso, Corbino, Larmor, Zeeman, and Faraday, and Van Vleck. So this is Vol'Kenshtein, who's helped put all this stuff together. And it's spelled here V-O-L and then apostrophe K-E-N-S-H-T-E-I-N, Vol'Kenshtein. I tend to say Stein if it's spelled Stein, and Stein only if it's spelled Stein. Well, gentle readers, that's about what we'll get to today. 59 minutes into the speech. Prager World of Art paperbacks, Herbert Read, A Concise History of Modern Sculpture. So Herbert Read is pretty great. And so in the time of Bergson and Home and about art and the theory of Croce and Bergson and art and Herbert Read, that this is a book on modern sculpture, and it does have some illustrations, and it has lots of references, and then so there's some pictures here of statuary or sculpture. Hans Arp Beethoven, Ludwig van, Edmund Burke, Paul Cézanne. That this is it's kind of a survey of the field, and in the modern mostly, quite modern these things later, because a lot of stuff is from the 20th century, and so yeah, this is a concise history of modern sculpture. Ultracentrifugation by J.S. McCall and B.J. Potter, laboratory monographs. So this is with regards to like the superfluid and the superdense, and the idea of for example, say you want to enrich nuclear materials to such a thing, but this is about blood, and ultracentrifugation. This book was written to provide technicians, undergraduates, and research workers in biology and biochemistry with a concise introduction to ultracentrifugation, or centrifugation. We're getting into the difference between centripetal and centrifugal force, and why it wouldn't add up necessarily one way or the other way, and with regards to things like the polar and non-polar solvents and the universal solvent and this kind of thing. We felt that this need existed because current coverage is in general restricted to brief sections, standard text, or to advanced accounts. Mathematical treatment in the theoretical sections has been kept to a minimum, but it was thought to be unsatisfactory merely to state equations without giving their derivations. These should present no difficulty to the reader who is familiar with the fundamental processes of calculus. Ultracentrifuge provides the laboratory work with an efficient and reliable means of separating and analyzing macromolecules. So this is from October 1972 about getting samples and these kinds of things. Well, gentle readers, then, this is some particular... maybe I'm going to look at this a little bit further, but it goes along with Vol'Kenshtein and the enzyme physics in the books.